Okay, welcome to this second video. And the second video builds directly on the first. In this one, we're going to take a calculator example to illustrate more of the use of the static. Now, this video is really all about the static class, as the previous video was. Why am I lingering on the static class? And why am I not going into what you might have heard are called objects? Right? Static classes are not objects. And why then am I spending any time with them? Because actually they're a good stepping stone. Static classes don't really have an enormous popularity. They're quite unpopular because they're very limited. But part of learning about their limitations here will also lead you to, I hope, appreciate what objects are about and what proper object-oriented programming is all about. So we are in a period of transition, and this period of transition helps us move towards a much more important concept, the concept of an object. So the purpose in this particular video will be to take another example, a very simple example, and work it through. But before I start the example, we're going to look, as I said, on a calculator. I wanted to pick up another meaning of the word static. Okay, so you might say, well, what does static actually mean? Well, it has many different meanings. And perhaps the most useful concept at this stage, when you're thinking about what the static, a good way of translating it is it means no state. And that is probably conceptually the absolute critical concept of it. Static classes lack states. So let me give you a very, very good example. Let's say that you said to me, Nad, I really like these static classes and I want to carry on using them. I don't want worried about objects. This is fine. I'll deal with this. I'll say to you, actually, static classes have no state. It has several consequences. Right? One of the consequences is you can't and you don't store data inside them. So what, you say to me? Well, next week when we come to looking at storing data and what that does, we'll step through all the issues of storing data. But state is defined by the state or the values occupying the data inside your object. Static classes don't have states, so they can't store data. They are straight away very, very limited. Their relative unpopularity is very closely tied to this limitation. However, from your point of view, having a static class which deals with console interactions and giving you a simple set of wrapper functions which allow you to pop something on a console window and receive data from a console is a really legitimate and a powerful thing to do. This next example of the calculator is a stepping stone. We're going to introduce it within limitations, and then in later week, we're going to change it, make it into an object, and show you the more power we have with objects. Okay, so let's get back to our window, and let's create inside that particular package, let's create a calculator. I could call this static calculator, but for the time being, I'm just going to call it calculator. And I'm not quite sure what it did then. I pressed the wrong button, so I'm just going to delete that. That's not what I wanted. I wanted Java class. Let's try that. I must have pressed interface by accident. Right, calculator. Okay, hit enter. There's my calculator class. Let's just take a very, very simple concept. I want to add two numbers. You give me two numbers and I want to add them. Right, how about that? Static returns a double, you pass it two doubles and it adds them. That's really, really quite useful. You can have a variation on that. You can have multiply, subtract, etc., etc. You're not storing data inside here. You're simply doing a process, a mechanism with the input data and returning the result. Okay, that's quite simple and useful use for a static class. Let's go back to our program and let's say double value get w. Let's very crudely. What I'll do is I will just write this so you don't have to see the painfulness of me coding it. But what I'm going to do is create two inputs here. And then I'm going to, okay, bear with me a second. Okay, I tend not to want to do that so you can code as I code, so I'll waffle a bit just to give you a second. I've got my first variable which receives the first number, second variable which receives my second one, and I want to process that. So I'm going to create a result. So if I call it double result, and then I'm going to call add num1, comma, which is my first one, and num2. Now it's going to complain it can't see add. So we have to have our import statement again. We have to have our location, the package it's sitting in, and if I type dot, it should appear. There's my calculator, and I can just put I need for static, sorry, to put asterisk. So all the functions inside are visible. That's what the asterisk means. It's a wildcard. If I had just left output to console here, look, for the console, I could have just chosen output to console and only use that if I wanted. By using the asterisk, I want everything from that static class. So the same thing with calculator. It's shorthand and a little bit lazy. Okay, so I've added it together, and then I'm going to output it to the console. So I'm going to say sum is space da da dum, and I'm going to pop in the word add. Now, if I'm lucky, it will throw a wobbly, and it has. It's not happy. Why is it not happy? If you actually pass the add function to a system out print line, it will implicitly convert that data. Well, hang on, that's because I've actually written add and I wanted to write result. Let's try that. Hang on, might not. Okay, it's behaving well. I didn't want it to behave well. It's implicitly converting it. But what I was about to say was, and that other thing was just a typo error, so ignore that. And what I was about to say is that this implicitly converts the second variable to the same data type as the first. You can't guarantee it. If you want to guarantee a conversion, use string.valueOf. We'll come back to that. Okay, so let's run it and let's see whether that works. So we come back to here, run that main. It prompt me for 2, give it a second, it's building it at the bottom. Okay, and number 1, 23.45, and the second one is 10.01, and the sum is 33.46. It's not much more complicated, but have a look at this. My program, in terms of complexity, has a lot more code mechanisms hidden away behind me. Now I'm using very simple examples here with the calculator. They're just single lines of code, and in the console output there's a few more lines of code. But you can start spotting, if I start defining my program as a series of concepts and steps, I can then very, very simply keep my main really short and have various functions which perform various duties for me. Now, what I would encourage you to do, if you haven't done it as part of the exercise, is create a multiply, create a subtract, and create a divide inside your calculator class and test it. Do it as a static. And before I finish this video, I want to now, before we move into the end, sort of move forward a week, and also I'll have a video on the worksheet in a moment and the next material, is I want to emphasize the fact that static has its use, so clearly does in this setting. So don't dismiss it out of hand.